So because it is a lengthy chapter, there are many formula also here and many ways of finding indefinite integration. But one thing you have to understand that in indefinite integration, it is not about lot of concepts. It is about formula, manipulation, and practice. So, like what happens in differential calculus, if application of derivatives and all those parts, you have to understand the concept. And if concept is clear, there are high chances that you can do the questions of JEE. But in indefinite integration, sometimes what happens that even if you have good grasp on the concept, there's not much concept here. Rules are there, formula are there. And if you have the, if you're not good at manipulation, if you are not good at, you have not got the click at that time, because it depends upon the click. Sometimes you may just get a click, okay, this is how we have to approach. Sometimes you may miss that click. So it is more upon the state of mind and the approach. So you should not be thinking that you can do any question of indefinite integration if you know everything, because it depends upon the situation also, and it depends upon the practice also, of course, but also click. So we'll start with formula first. So the formula of indefinite integration, we all know, like we have integration of cos x, which is sin x. And then these all formula we know, like sin x integration will be minus cos x. And then we have sec square integration, which will be tan x, because it is the inverse process of differentiation. Plus constant of integration would of course be there. So these are formula. I expect that you remember. One thing which we have to understand in indefinite integration, like if you remember integration of 1 by root over 1 minus x square. So what is that? Can anyone tell me?
Sin inverse x plus c.
Okay, sine inverse x, correct? No issue. And if I write it as minus cos inverse x plus c, then am I correct?
Yes, sir.
Yeah, because sine inverse x derivative is 1 by root over 1 minus x square, and cos inverse x derivative is minus 1 by root over 1 minus x square. So both is correct. So does it mean that sine inverse x and minus cos inverse x are same? Of course, it does not mean this. This is wrong. So how can we explain this situation that sine inverse x and minus cos inverse x both are the integral? How can you explain this situation? So if you try to explain this, then one thing is important, that if you remember, there is an identity that cos inverse x plus sine inverse x is equal to pi by 2. And you can write cos inverse x as pi by 2 minus sine inverse x. So if you replace in this formula, where minus cos inverse x plus c is given, pi by 2 minus sine inverse x plus c. So it will become sine inverse x plus c minus pi by 2. Now this c minus pi by 2 is also a constant of integration because it does not contain x. So this constant of integration you can name as something else, like c2 you can name it as, and this one as c1. So this is c1, and c1 minus pi by 2 is c2. So you can say that this formula here as constant of integration c2, this as constant of integration c1. So both is correct. The only thing which need to be understood here is that the constant of integration may be different, which is not dependent upon x. That is the difference of the constant is some constant value. It is not dependent upon x. So both is correct. So the c is not same in both the cases. One is another constant, another constant. Is this clear?
Yes, sir.
Yes, sir.
Okay. So this is one thing which may be little tricky sometimes, and questions may be asked based on this. Now, all other formula, there are some substitution formula also. By substitution, we get few formula. Like if we have, suppose integration of tan x. So we know that we don't know any function whose derivative is tan x, because we remember the integration by derivative. So tan x is the derivative is none of the known functions. So here what we will do, we'll write it as sin x by cos x dx. And then what we'll do, we'll write cos x as t, and sin x dx will be minus dt. So minus ln t plus c, which is ln 1 by t plus c. So this will be ln 1 by t we took as cos x. So 1 by cos x plus c, which will be ln sec x plus c. So we get a formula. And this formula we have not got by differentiation inverse process. Instead of that, we have done by substitution. So integration of tan x dx is equal to log of sec x plus c. So in this manner, there are many other formula also. Like we have uh, cot x integration, that is log of. Do you remember what is integration of cot x?
Sin
Sin
x.
x.
Sin x.
Log of sin x, correct. So there also we follow the same process. Then if we have sec x, then its integration will be log of sec x plus tan x. So similarly, we have integration of cos sec x, and this list goes on. Another thing is based on trigonometric identities also we solve the question based on trigonometric identities, like we can have, and you have to remember these trigonometric identities, though you have studied it in class 11th, but like if it is given integration of cos square x, simple question. So again, how to do it? So what we'll do, we will multiply by 2, divide by 2, and 2 cos square x, we can write it as 1 plus cos 2x. So 1 dx integration will be x, and cos 2x will be sin 2x by 2 plus c. So this is how trigonometric identity helped us in making this high power of the trigonometric function as multiple of the angle. The degree has decreased. Now the degree is not 2, degree is 1. But yes, the angle has multiplied with 2. So that is quite easy to find the integration, because we know that if there is a function fx whose integral is capital Fx plus c, then integral of f of ax plus b. That means if we take the input as ax plus b, then the final answer will be capital F of ax plus b by a plus c. So this is how we do linear extension. This is called linear extension. So this in only linear case we do. We don't do this in quadratic. If suppose x is replaced by ax square plus bx plus c. So there is nothing like this there. So it is for this purpose only, that linear, if you replace x by a linear term ax plus b, then this is how the final answer will change it into. Like if you have tan of 3x minus 2 dx. So since we know that tan x integration is log of sec x, we have just seen, so this will be log of sec 3x minus 2 by coefficient of x, which is 3 plus c. So this is linearly, this will give you the corresponding answer. So this is something which we have to understand. So let us see a few questions based on these concepts which we have done till now. Then we will move on to another concepts. If you have any question till here, you can ask. Okay. So we have few previous year questions which we may do based on the concepts which we have done till now. So this is was asked in, there was some exam called Roorkee exam earlier. when IT Roorkee was a different institute, just Roorkee. So there was a example x by e to the power x. So you try this question first, and then there is a second question. This question says integral of dx upon x root over 2ax minus x square. So just try these two questions first. And the basic thing is to use substitution right now. You have to think about substitution and you will be able to solve it. Okay, Aditya has also joined. And Aditya, have you got what we were doing just now? Madhya answer is X. So I don't have access to the answer. I will also solve it. So let's see others what they are responding. Then we will discuss. So this is the answer which Marita is giving. So I can give you a hint here, like if you'll try to approach this first question, do one thing. Take 1 plus e to the power x. There are other ways also. This is the most suitable way. T is equal to 1 plus e to the power x. Then you can proceed. So if you take t is equal to 1 plus e to the power x, what will happen here? That dt is equal to e to the power x dx, right? And we have dx is equal to dt by e to the power x. Now e to the power x is t minus 1. So dt by t minus 1. Here, from here, we can say e to the power x is t minus 1. So when you do this, what happens? That this integration becomes t which is 1 plus e to the power x, and dx is dt by t minus 1. This becomes like this. Have you approached in the similar manner, Marita?
No, so I actually added and subtracted e raised to x to the numerator. Then I split the fraction.
You added e to the power x to the numerator. Okay, that is also fine, I think. That is also perfect. So let us first discuss this approach, then we'll discuss that approach also. Then also you'll get the result. So if you'll add and subtract them. So let us discuss this. What we do here, we get this one. Okay. Then we do 1 by t minus 1 by plus. Since we have to get 1 in the numerator, no? Minus 1 by t by 1 by t minus 1. We can write it like this. Because when you take the LCM, the numerator will be minus t plus 1 plus t. So tt will cancel and you'll get plus 1. This will be minus log t after integration plus log of t minus 1. And we know that t is 1 plus e to the power x. So log t will be log of 1 plus e to the power x with a minus sign. And log of t minus 1 will be log of e to the power x. So you get from the second term, you get x only, from the first minus log 1 plus e to the power x plus constant of integration. The answer is slightly different. So we will approach by your method also. I think this method is clear to everyone. We get this answer.
Yes, sir.
Okay. Now Marita is saying that she wants to do it like this, that dx by 1 plus e to the power x. So that would be 1 plus e to the power x minus e to the power x by 1 plus e to the power x dx. We can write it like this. That means we have added e to the power x and subtracted e to the power x in the numerator. That will become 0 and 1 plus 0 will be 1. Now we separate 1 plus e to the power x with 1 plus e to the power x and minus e to the power x by 1 plus e to the power x dx. Now this 1 plus e to the power x and 1 plus e to the power x will cancel and the value will be dx, and integration of dx is x minus integration of e to the power x by 1 plus e to the power x dx. So the first part x is coming fine. For Marita is also it is coming fine. Next one, if you do 1 plus e to the power x, let us take as t. So e to the power x dx will be equal to dt. This is what will happen. And e to the power x dx is in the numerator. So dt will be in the numerator and t in the denominator. So this will be x minus log of, and what you have taken t as 1 plus e to the power x. So 1 plus e to the power x plus c. So the answer is by either your method, Marita, or by this method, which we have just discussed before this. You are getting the same answer. So might be you have done fine. This part is fine, but your the second part is having some mistake, I think. Is it
Okay, sir.
okay? Can you identify your mistake? So you can write these steps. And then we have another question, which is dx by x. This one I'm writing it here. This question is dx by x root over 2ax minus x square integral. This is what we have now. Yeah. So here it is basically algebraic terms given. There is no exponential term. There is no logarithmic term. There is no trigonometric term. So how would you approach this question?
So how do we do this question?
Okay. Uh, so let us discuss. I think others have also tried enough. So what we can do here is there are various ways to do this question. By substitution, if you want to do this question, you can do it like this, that mm, x you take as common and this will be, yeah. So let us take 2ax minus x square as t. Let us take it as, in fact, t square also you can take. Let us take as t. So 2a minus 2x dx will be equal to dt when you differentiate it. That is 2a minus x dx is equal to dt. Fine. And then you do the substitution. So x would be as it is, dx would be dt by 2 into a minus x, and this will be root over t. Now let us see this part, because we have to make every term in terms of t. So this will be 2ax minus x square root over t, and you can write ax minus x square is, okay, this is quadratic now. So I think we should have only one method now, which is let us do it by different approach because it is quadratic. So dx by x root over 2ax minus x square we have, and we can write it as x root over 2ax minus x square minus a square plus a square. So why we have done this, it will be clear in 1-2 steps. Since here it is 2ax minus x square, I have subtracted minus a square and I have added plus a square to it. When we do this, what will happen, that the term from here to here will be, this is a square, this we have written. The term from these three terms, I take minus common. So it will be actually a minus x whole square. We can write it like this because when you expand it, you will get a square, x square, and minus 2x. And the final result will be same, which is written over here. So you can do it like this. Little bit of thought process is involved here, but there is no other way by which you can do the substitution. So this will be x root over a square minus a minus x whole square. Now in the next step, we can take a minus x as a sine theta. Why we want to take a minus x as a sine theta? Because if you see here, a square minus a minus x whole square, it will be a square minus a minus x whole square as a square minus a square sine square theta. When you do put it here, a minus x, this will be a square cos square theta, because 1 minus sine square theta is cos square theta. So this root over a square cos square theta will be a cos theta. So this is how you can simplify it. Now what is x? X is a minus a sine theta. From here, x you can say as a minus a sine theta. So this a we take common, 1 minus sine theta. This is how we write it. X as a into 1 minus sine theta. Dx would be from here minus a cos theta d theta. When you will differentiate x, you will get the derivative of a as 0 and sine theta will be cos theta. So minus a cos theta d theta. So this is what we are doing here. Now after doing this, this a cos theta will get cancelled and it will become minus 1 by a outside, which is a constant, d theta by 1 minus sine theta. This is what we are getting. So till here it is fine. D theta by 1 minus sine theta. So two important processes we have applied till here. One is that we have completed the square. This was incomplete. We completed the square like this and we wrote it like this. This is the first thing which you have to think. Second thing, after completing the square, you have to think it like this, that coming out of the square root means that this should be like 1 minus sine square theta or 1 minus cos square theta. So that will give you cos square theta or sine square theta, which will come out of the under root without any root. So we assume that a minus x is equal to a sine theta. And from there, we are able to take this out of the under root as a cos theta. And other values are getting the corresponding values similarly from here. So we are getting this. Now we have the only thing is to integrate minus 1 by a d theta by 1 minus sine theta. This we can do like this, that we can multiply 1 plus sine theta in the numerator and 1 plus sine theta in the denominator, which will give you 1 minus sine square theta. That will be cos square theta d theta. So this is, I think, little difficult question, but still you can think about it. Minus 1 by a. Now it is done. Now it is not difficult. Take a square theta d theta plus sine theta by cos theta is tan theta into sec theta d theta. So we have separated them. 1 by cos square theta, sec square theta, and sine theta by cos square theta, tan theta, sec theta. So minus 1 by a, sec square theta is tan theta, and tan theta sec theta is sec theta. Plus constant of integration we can write outside. So this is here. Now what we assumed was that a minus x is equal to a sine theta. So sine theta was a minus x by a. We assume that sine theta is equal to a minus x by a. So finally, we have to do the back substitution. Back substitution means that we can't give the answer in terms of x. We have to write it in terms of theta. We have to write it in terms of x. So tan theta is perpendicular by base. Perpendicular is same as x. Base would be root over a square minus a minus x whole square. And sec theta is hypotenuse by base. So hypotenuse is a, and base will be root over a square minus a minus x whole square plus c, because this is the perpendicular part, this is the hypotenuse part. So this would become minus 1 by a to a minus x by root over a square minus a minus x whole square plus c. And then I will give you the time to write all of this. So this will become x minus 2a, let us absorb the minus sign, by a root over, and you will again expand this and you will get it as uh, 2ax minus x square as it was in the question plus c. So this will be your answer. You can start writing from here. So some questions may be there which are little difficult in exam and it will take time for you to think about it. And some are easy. So your purpose is basically to score marks. So if you see these type of questions which are little difficult, you do it in the second round. First round, do average or easy questions. Then you will get some time in the end for revision. Then you will do all the remaining questions. But if you, again, the same thing is there. In indefinite integration, if you don't get the click in the first attempt or the second attempt, don't keep on wasting time on that. Just go on to the next question. Later on, when you will have time, you will come back to that question and think about in the different way. I will scroll it down, so you would be able to write. If you have problem in any step, you can just ask me. I'm scrolling it down further. So the next question we have is, then we will move on to the further theory based on substitution and all those things. We have one more question. X dx upon 1 minus x cot x. Here the hint would be, right. It is not a lengthy question. You would be able to do this. And then proceed. After using that substitution, you can take the denominator as t and check whether its derivative is the numerator or something like that. I'm coming in a minute. Okay, answers have come from few people. Uh, Adriel is given log mod sin x minus x cos x. Krishna is also giving the same, and Marita is also giving the same. Yeah, I think this is the answer. And if you proceed in the manner which we have started, that this cot x is cos x by sin x, so this will become minus x cos x, and this will become sin x after taking LCM, and the sin x will go here also, dx. Now, when you take the denominator t, sin x minus x cos x, then the derivative will be sin x is cos x, and x cos x will be cos x minus x sin x, because you will do product rule of differentiation. So cos x and minus cos x will cancel and you get x sin x. So luckily, what you are getting is x sin x dx. What you are getting is dt as x sin x dx, which is the numerator, and t is the denominator. So this is what we are getting here. So this will be log of mod t plus c, and then we will say that as we have given the answer, all of you, log of mod of sin x minus x cos x plus c and this will be the right answer. So these were basically based on substitution. So different type of substitutions were there, like somewhere you have to do the trigonometric substitution as you saw in the previous question. Here you have to do the substitution of log. So these substitution are required. Next is trigonometric identity. So let us see one question or two questions on trigonometric identities. What are the trigonometric identities which we have to remember? Some of the important one is like cos 2 theta is equal to 2 cos square theta minus 1, or it is also 1 minus 2 sine square theta. And one more is there, it is cos square theta minus sine square theta, which you may need sometime only. And 1 minus tan square theta by 1 plus tan square theta. So these type of trigonometric identities you have to remember. Sine 2 theta is 2 sine theta cos theta, or 2 tan theta by 1 plus tan square theta. And there are some other also, but these are the important ones. Now, if we see a question like uh, sine to the power 4x into cos to the power 3x dx. So how can you try this one? So hint is that see the powers. That is the power of sine is 4, power of cos is 3. So power is even in case of sine and power is odd in case of cos. So what is the thumb rule is that we take the function or substitute the function as t, where the sine or the cos has the even power. That means if you want to substitute here, you will take t as sin x, not as cos x, because power of sine is even, power cos is odd. So odd one we don't substitute, we substitute even one. Someone has exit from this. Adriel is there, Aditya, Krishna, Marita is there. Welcome. Anyways, let us continue. So this will be t to the power 4 and write cos cube x as cos square x into cos x. So this cos square x can be written as 1 minus sine square x, which will be t square. Okay, and this cos x will multiply with dx and dt will be cos x dx. Now the part is not difficult. It is integration of t to the power 4 dt minus t to the power 6 dt, and it will be t to the power 5 by 5 minus t to the power 7 by 7 plus c. And t is sine x, so sine to the power 5x by 5 minus sine to the power 7x by 7 plus c. So this will be the answer. So this is a rule actually in such type of questions where sine power and cos power are multiplied. Yeah, Marita, you have got the correct answer. So where sine power and cos power is multiplied, that we take the substitution which of the function which does not have the odd power. Now we have few formula. What are those formula based on which we get some question? Like integral of 1 by a square minus x square, integral of 1 by x square minus a square, integral of 1 by a square plus x square, this will be 1 by 2a log of a plus x by a minus x. This will be 1 by 2a log of x minus a by x plus a. This will be 1 by a tan inverse of x by a. Then we have integral of 1 by root over a square minus x square. This will be sine inverse of x by a plus c. Everywhere c is there. This formula can be derived, but we are not going into the derivation, of course. 1 by a square plus x square under root is equal to log of mod of x plus root over x square plus a square. And then 1 by root over x square minus a square is log of mod of x plus root over x square minus a square. So these are some of the important formula which we need to remember so that questions can be done based on them. You just go through this, write this down, and I am giving you question. So one question could be like this, that we have integral of dx upon root over minus x square plus 2x minus 3. You can do this one first. Hello, Priya has joined. Priya, we are doing indefinite integration. You joined in between. I hope you will understand what we are doing. This is a question here, which we need to do.
Yes.
The formula are same as given here. These are the formula. You have to apply the appropriate formula. So of course you can't directly apply the formula. So the hint is first complete the square. What will you get after completing the square? Don't just start doing it after that. Just tell me what you get after completing the square. If you complete this minus x square plus 2x minus 3, what will you get? Can you tell me that?
So root of root 2 square minus x minus 1 whole square.
Root 2 square minus x minus 1 whole square. Okay, this is what you are getting, but don't you think this is not right?
Sir, I'm
Because
getting minus root 2 square.
Yeah, this
yeah,
extra minus.
there is extra minus root. So because this will become minus 2 minus x square plus 1 minus 2x, and then you will get minus x square plus 2x and then minus 3. So if you do it by completing the square, what you are getting is minus root 2 square minus x minus 1 whole square. Now, can this be integrated? This is a negative quantity always, because this is negative and a square is also greater than equal to 0. So minus sign before it is also negative. So overall, this is a negative. A square root is there and negative square root is not real. So this is not integrable, does not exist. So you make it an option like this, and you have to, don't just start doing it, just see whether it is feasible also or not. Now, if the question is being changed from this one to this one, that it is dx by root over minus x square plus 2x plus 3, then what will happen?
Then we can get it as plus root 2 whole square minus x minus 1 whole square.
Just do it, because it will not be plus root 2 square. It will be something else. Minus x square plus 2x plus 3 will be
2 square minus x minus 1 whole square.
correct. 2 square minus x minus 1 whole square. So not root 2 square, it will be 2 square. 2 square minus x minus 1 whole square under root. Now when you want to integrate this dx by root over 2 square minus x minus 1 whole square, the formula which will be applied is a square minus x square. The formula which be under root of a square minus x square, this formula. And x is being replaced by x minus 1. So this will be sine inverse of x minus 1 by a, which is 2 plus c. So you have to just do the adjustment and then plug it into the appropriate formula. Now, let us see one question. This form. So I'm not telling you which particular concept will be applied, but any of the concepts which we have studied till now in today's class will be applied in this question. So this is x square by root over 16 minus x square dx. And another one is one upon 1 plus 4x square dx. Second one is relatively easy. It is not too much of a work to be done in second one. You have to just see the proper formula. For the first one, you have to think a little bit. Someone has given the answers. Sir, for the first one, should we take x as a sine theta like the other question? Yes. So correct, Adil. So a sine theta you will take, and that a would be 4 here. So you can take x is equal to 4 sine theta, and then numerator will be 16 sine square theta, and the denominator will be 16 minus 16 sine square theta under root, which will be finally 4 cos theta. And dx will be 4 cos theta d theta, the derivative. Yes, dx will be 4 cos theta d theta. So you will cancel these terms and you'll get 16 sine square theta d theta. So once you have used substitution, this is what we studied first in this class, substitution. Then next what you will do is use trigonometric identity. What trigonometric identity will you use here? Can you tell me after this?
Cos 2 theta is equal to 1 minus 2 sine square theta.
Yeah, cos 2 theta is 1 minus 2 sine square theta. So it means that 2 sine square theta is equal to 1 minus cos 2 theta. So this will become by 2 and 2 multiplied 1 minus cos 2 theta d theta. Cos 2 theta d theta. So this will be 8 into theta minus sine 2 theta by 2 plus constant of integration. And this you can write it as 8 theta minus, and then open sine 2 theta as 2 sine theta cos theta. So it will be 8 sine theta cos theta plus c. Now you know that from here sine theta is x by 4. So cos theta will be root over 4 minus x square by 16 over. It will be 1 minus x square by 16. So it will be 16 minus x square by 4. So this you can write it as 8 theta is sine inverse x by 4 and minus 8 sine theta into cos theta will be x into root over 16 minus x square by 16 plus c. So 8 sine inverse of x by 4 minus x root over 16 minus x square by 2. This will be the final answer. So in the end also, when you have integrated and done everything, then also you have to think that you have to do the back substitution. So how can you do the back substitution? That is also important. Like here you have taken sine theta is equal to x by 4, but you have to also think that when you have to find cos theta, then what you will do, like root over 1 minus sine square theta, you will do these all things. Second one is easy, so I'm not discussing that. Here it is simply, let me write it here, that it will be 1 by 1 plus 2x whole square dx, and this is 1 square. So it is of the form a square plus x square. So the formula for that is 1 by a, so a is 1 only. So 1 by 1 is 1. Tan inverse of x by a, that is 2x by 1 is 2x. Upon 2 will be there because it is a linear extension. We studied now. So let me write it here if you get confused. Dx by 1 plus 4x square is equal to dx by 1 plus 2x whole square. This is 1 square. So 1 by a tan inverse of x by a, the formula, upon the coefficient of x, which is 2, the linear extension. Tan inverse 2x upon 2 plus, don't divide by 2 to the angle, it will be outside. Just write this one. Now, one more topic we will do today, that is partial fraction. Then in the next indefinite integration class, we will do other topics like partial fraction we will do today. This is the last one. So partial fraction, you may have remembered that it is of the form like px plus q by x minus ax minus b, and you have to write this one as a by x minus a plus b by x minus b, and you have to find the proper value of capital A, capital B, so that you can do the partial fraction. Similarly, you get other cases also like px square plus qx plus r is there, and here it is x minus a, x minus b, x minus c. So you can write it as a by x minus a plus b by x minus b plus capital C, this is by x minus c. Or you can have px plus q upon x minus a whole square. So you can write it as a upon x minus a plus b upon x minus a whole square. This is a different type x minus a. Then you may also come across like px plus q upon x minus a whole square b, and this is px square plus qx minus b. This is x minus a whole square plus c by x minus b. One more case is like you have p x square plus qx plus r upon x square plus bx plus c into x minus a. This is cubic, so but all the three factors are not there. So a by x minus a plus b by bx plus c by x square plus bx plus c. So based on these tools, these are basically tools. These are not the formula, these are the tools. So if I give you a question that this has been again asked in MPPET exam, x upon x minus 2, x minus 1 dx. So how can you do this by the partial fraction? One student has got disjoint in between. I don't remember the name. Who was that person? Adriel is there, Aditya is there, Krishna and Marita is there. Who else was there? Can anyone tell me?
Sir, I had to leave in between.
Sorry, Priyadarshini. Oh, so you have logged in by some other name.
Yeah, I had to use another device.
Okay, that's why I thought what happened. So here what you have to do is first take this out of the integration. I'm giving you the hint and write it as a upon x minus 2 plus b upon x minus 1. And then find proper a and b for which this is true. And how do we do that? We take the LCM like this. And then we equate the numerator. Okay. So Marita is saying that 2 log x minus 2 minus log x minus 1. That Marita has got the value of a as 2 and b as minus 1. That is how she has got this answer. So let us see whether this value is correct or not. Aditya is also giving the same answer. Adil is also giving the same answer. So I think it is okay. So if we get a as 2, so 2x minus x will be x, fine for this, and minus 2 and plus 2 will be 0. Yeah, perfect. So all of your answer is correct. Correct. So it is log, and as Adil has written it, it is in terms of multiplication division. Then also you can write. Let us see another question. This question was also asked in an exam, competitive exam earlier. X square plus x minus 1 by x square plus x minus 60x. Now here, will we do the partial fraction just as it is, or before that we have to do something, because the degree of numerator is equal to the degree of denominator. So this is not a proper fraction. This is an improper fraction. So in improper fraction, what we do first? Can anyone tell me?
We should divide.
Two of you were speaking. I didn't get any one of you.
Divide.
We should divide.
Yeah, divide. That is polynomial division. So you have to divide x square plus x minus 1 with x square plus x minus 6, because we have to always keep this in mind that when we are doing partial fraction, the degree of numerator must be less than the degree of denominator, which is not true here. So we will do this. So just do this and get the answer. So that's what answer we are getting. Okay, someone has given the answer. Quotient 1, remainder 5. Okay. So can we write it like this now? If we have ideally saying that quotient 1, remainder 5. So this is how we write it. Now when we write it like this, 1 will be integrated as x. Now we have to integrate this one. So we do the middle term splitting, and in that case we get x plus 3 into x minus 2 dx. Now 5 upon x plus 3 into x minus 2. What will be the partial fraction for this? Would you get it? 1 by, this is a small one, so we can think about it mentally. If we do this one, x plus 3 minus of x minus 2, you will get this one, right? What will be the final answer then? So I think you can get the answer by now. Won't it be like x plus 1 by x minus 2 integral will be log of x minus 2, and 1 by integration pass it, nothing there in, almost nothing there in partial fraction. The all things are concentrated on the tool of partial fraction. Once you have completed with the tool of partial fraction, integration is just only one step that you have to integrate by using a formula. And that is mostly 1 by x is log x. Is it clear to everyone?
Yes, sir.
Okay. So some more parts are remaining in indefinite integration. As I said, that by parts is remaining. Some more formula are there which are being applied, which is like 6 formula we did, 3 more formula are there, and 1, 2 things are more which we'll do. Then this indefinite integration will get completed. So till now, do enough of practice and all the best. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.